In a previous video, I had talked about how we could start designing our wheels for an F1 racing car. In this video, we're going to build on top of that by using parameters in our design and some tolerances as well. So here I have open in front of me a wheel profile. You can see that I have not constrained or put dimensions on this yet other than my little fillets, and I am using a metric file in Autodesk Inventor Professional 2022. So what we're going to be doing here is learning how we can insert and use parameters to make our wheel designs much more efficient, much easier to come back and modify, and much easier for someone else to be able to use that file and modify, because an F1 team is always composed of more than one member, and you might be sharing these files amongst your team, and other people need to understand how they're working, what you were thinking about when you designed it. So here are our technical regulations. These are the 2022 technical regulations from F1, and these are all the constricting regulations with regards just to the wheels. So not with the wheel to the car body or anything, but just with the wheel itself. Now on here, when I'm dealing with parameters, I'm just interested in the dimensions, so the constricting dimensions. So for example, T7.4 is our track contact width, and we have a different contact width for our front and rear wheels. T7.5 is our diameter, and here we have a absolute minimum and an absolute maximum, and this is for both the front and rear wheels. So these are the two regulations that I'm actually going to be concerned with here in creating my parameters. So let's start with the track contact width. So in Inventor, what I'm going to do is I'm actually going to come up to my quick access toolbar here at the very top, and you see this little button called F of X. If you left click on that, it's going to open up all of the parameters you have in Inventor. Now if you've started placing dimensions on here, filleting with radius values, or if you've inserted any dimensions from a previous file or from Excel, all of those will be listed here. Right now, the only things you see here on mine are my two dimensions that are my two radiuses for my fillets here that we can see, and that's it. I haven't put anything else in here, so it's pretty empty. What we're going to do is just create some parameters. So at the bottom here, there's a button called Add Numeric. So I'm going to click on the Add Numeric, and it's going to create a user parameter. Now the first thing we need to do is give this a name. Now don't just call it parameter 1, parameter 2, because those are meaningless names. We have no idea what those are. Let's give it a name that we're actually going to remember. So something like track contact width. Now this is a meaningful name. We know what it refers to. And what we're going to do is we're actually going to put in that value. So if I look at the regulations here, if I'm designing for my front wheels, my contact width is going to be 12.0 millimeters as a minimum. So I'm going to start by just putting in underneath the equation, I'm going to put in 12.0. Now make sure your units are correct. If you need to change the units right here, mine are millimeters, but if yours are anything else, you can just left click on that, come in here, and find the units that you need right here. Now, we've created this parameter. Let's move on. Let's create our next one. So the next parameter I'm concerned with is my wheel diameter. So I'm going to create another numeric parameter here, and I'm going to call this one, actually I'm going to go even further. I'm going to say outer wheel diameter. So I know that this is the complete outside diameter of my wheel, or my overall diameter. And I'm going to come in here, and this one has to be between 28 and 34. I'm going to put in the minimum right now as 28. And again, just make sure that's in millimeters. So now I've created my two parameters. Some of the other ones I might want to put in might be my axle diameter, so the diameter of the axle fitting into my wheel. So I'm going to create one of those right now as well. So I'm going to say axle diameter, and I'm going to say it is, let's say 4.5 right now. So this, I'm going to build in my tolerance right in here. So 4.5 is the diameter in millimeters that I'm going to go with. Now with this little design here, if I can drag this guy out of the way, we can see down here what I'm designing for is an axle, but I'm also designing for a bearing. And I'm going to be designing for this little bearing right here. This guy does not have a flange on him. So what I've done is just left a little space right here for him to fit in. So I'm going to create a parameter for his diameter as well. So I'm going to go add numeric. I'm going to say this is my bearing, and I'm actually going to go underscore outer diameter. So this will be the overall diameter of my bearing that needs to fit in here. And for this one, we're going to say, oh, wrong number there. We're going to go with 9.5. Okay. And our next one is going to be our bearing depth. And that's how far it sits into the wheel right here where my mouse is. And that one is going to be 4.1. Okay, so under here we can see user parameters. I've created these 5 parameters. They're ready to be used in my sketch. Right now they're just kind of sitting here. They're in the file, but they're not at all dimensioned onto the sketch yet. So that's what we're going to do next. So I'm going to click on Done and start just adding some dimensions to my shape here. So I'm going to click on my dimension button, and let's start with that track contact width, which is this upper dimension right here. So I'm going to place that dimension, and instead of just typing in my value, I'm going to hit this little arrow over here on the right hand side and come down to list parameters. And in here it's going to list all those user parameters that I made. So this one is my track contact width, so I'm just going to grab that one and click the little green check mark. And we can see that it's putting in a value of 12. And we can see with the little f of x there, it's telling us that this is a little functional value. So this isn't a static value that I typed in, it's actually a function. Okay, so let's move on. Let's do my overall wheel diameter now. So I'm going to dimension between the top and bottom half of my wheel here. Remember that this right here is just the halfway point of my wheel. So I'm going to right click, go to linear diameter, so I get the overall diameter of my wheel. Place that one, hit the little check mark, or sorry, arrow, go to list parameters, and this one is my outer wheel diameter, so the overall diameter of my wheel. Click the green check mark. Okay, so now we can move on. One of the other ones I did was my axle diameter, so I'm going to place that one right now. Again, I'm going to right click, go to linear diameter, and this one was my axle diameter. The next one I'm going to do is my bearing diameter. Okay. And you can see as I place these, it's just like typing in a number when you're editing your dimensions. Inventor is updating my sketch for me. As my lines become fully constrained, you can see they're going from purple to black here. And those values are being listed, so I can still see what the value is in here. Okay, so the next one was my bearing depth. I'll just drag that out of the way down here. Okay, so now I've used all 5 user input parameters that I've created. So 1, 2, 3, 4, 5, they're all on here, and now the rest of the dimensions I place on here, I can just do those by placing dimensions and editing them. The other option I have is I can create parameters right in here. So let's go ahead and do that. I'm going to dimension the shell thickness of my wheel here, or the lip of my wheel. So I'm going to dimension from the outer diameter of my wheel to this line right here. And I want this to be 2 millimeters thick. So that means when I revolve my wheel here, just the outer shell, or the part that's going to be touching the track, is only 2 millimeters thick from here to here. Now I can leave that at 2, but the problem is, let's take a look at that. If I go to my f of x button, or my parameters button here again at my quick access toolbar at the top, what it does is that's the last one I placed, so that's D7. It just has a parameter called D7 and a depth of 2 millimeters. So for someone that you might be sharing this file with, or anyone else that needs to come back and edit it, or let's be honest, if I come back and edit this, let's say in a month's time, my memory might not be that great. I might not have a hot clue what D7 is. So what we can do is we can actually name that parameter right here. So even after I've placed it on my sketch here, there it is, I can come into my parameters dialog box and I can give it a name right here. So I might call this one, oh, what's a good name for this? Let's go wheel thickness. Okay. So again, trying to give it a name that's pretty meaningful, meaningful so that we understand what it is, so that we can say, okay, the wheel thickness right now is 2 millimeters. Click done. Okay. So I'm going to go ahead here. I'm going to place this dimension. I'm going to equal this one to my wheel thickness as well. So I'm going to go to list parameters and choose wheel thickness. So you can see that after, I should have done that a little slower, so that after you've even created a parameter in here, you can come in and it's listed in our parameter section here, so I can choose that new wheel thickness and place it in here. Maybe only place it once though, not twice. Okay, so it is a usable parameter after I've already created it. Okay, and I'm just going to quickly throw some dimensions on here as well. Okay. How big do I want that to be? Maybe even a little smaller. Okay. So that's what I'm going to be working with just to keep going here. So if I go again up to my quick access toolbar, open up those parameters, you can see that this is quite a bit busier than what it was when I started and I just had those two little fillet radiuses on here. I've now created a bunch of dimensions here, D2, D3, D4, D5, D6, that refer to those user parameters down here. I've also created this parameter right here called wheel thickness that I've actually named right in my file, and it has a value. I've created another dimension here that is the same as the wheel thickness. That was this little guy right here. So this is quite a bit busier, but here's the beautiful thing about it. If I was to share this file with someone, now they have a couple options. They can open up the wheel, they can come into this sketch, and they can try to make sense of all the lines, the dimensions, the fillets, the chamfers, everything else you have in here, and they can just start double-clicking on your dimensions and changing values. Okay, that's one way to come in and modify, but that's a pretty inefficient way, especially because some of your F1 car parts are going to be much, much, much more complex than just half of a wheel profile. So this is a good one to learn about parameters on. Instead, what that person can do is they can open up your wheel file, come in here, go into your parameters and say, okay, we 3D printed this wheel, we tried to put our car together, but the axle would not fit. The axle hole in the wheel was too small for the axles we designed to fit in there. So all they need to do is change the axle diameter, so they can go, look, 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 there's the axle diameter, and this needs to become 5 instead. So they update it here. We can look up at the model parameters. These are the parameters that are actually on our sketch. We find the one that said axle diameter, and we can see that it is now equal to 5 up here. We can also double check that right in here, so we can come in, we can see, okay, this is where the axle goes, and we can see that it's been updated to a diameter of 5. So using our parameters is a really quick, easy, and very understandable way to come in and just quickly change those values for things that maybe didn't quite work when you manufactured your parts and you were ready to test them. Okay, so that's how we can use parameters in here. Now I'm briefly going to touch about how you can see which parameters are placed where, because right now this is a bit of a jumbled mess with all these dimensions on here. So when you're in a sketch, you can just hit escape on your keyboard a few times so you have nothing open. Then you can right click, go off into the middle of nowhere here, so right click and come down to dimension display. And this will actually change how your dimensions show up in a sketch. So if we have value chosen, which we have right now, all you're going to see are the numbers or the static values that are currently set in our sketch. Instead, if we come down to name, we turn on name, and you can actually see what the names of these parameters are. Now you can see the difference between creating user parameters and naming the parameters right in our file. So for example, we know that this one is track contact width. However, because what we created that one before we placed our dimensions, it actually gave it a new name in our file here, which isn't super handy when we're naming it like this. Okay, now versus this is the one where we placed the dimension first and named it after, and you can see that the name does show up. So there's some pros and cons to defining our user parameters before putting our dimensions in, or defining our parameters after placing our dimensions. So they're not quite the same thing. Okay? Now, if we keep going, if we come down to dimension display, there's 3 other settings. You can change it to expression, which tells us the mathematical expressions you've placed in here. Now, I didn't do anything too crazy in this one. In fact, I didn't do anything crazy at all in this one. But if you put any equations in here, such as this depth is equal to this depth divided by 2, those equations would show up so that you could see the mathematical equations you've typed in. And then we have tolerances, which will show us our tolerances, and then we have precise value, which again will show us the exact precise value that this is currently measuring. So this is kind of a handy little tool for you to come in and actually flip through the different ways you can see your dimensions in your sketches. So I'm going to go back to value. Okay, so I'm going to finish sketch, and I'm just going to quickly revolve this so that I actually have a wheel in front of me. So this is what that hard work and parameters has gotten me so far. It's a pretty basic little wheel, has a spot right here for the bearing to sit into. And again, just for clarification, our bearing, here's a top view of our bearing. It's just a little donut-shaped cylinder. So that just plops right in here. And then our axle, which is one of these 3 guys right here, would insert through the bearing into the wheel right here and sit right inside there. And this one would be a friction fit, is the plan. Okay. Let's now talk a little bit about tolerances quickly. So I'm working in my same sketch here. I just double-clicked on my sketch to open it. And let's add a tolerance. So why would we add tolerances? Well, if we take a look at our regulations again here, T7.5 has a minimum of 28.0 and a maximum of 34.0 millimeters. So we have a tolerance here where our wheel can either be equal to 28, equal to 34, or any value possible in between those 2 numbers. So let's add that into our wheel diameter right here. So I'm going to double click on this dimension, and I'm going to hit this little arrow again just like we did for the parameters, but this time I'm going to come down to tolerance. And in here, Inventor will actually let us insert our tolerances right inside our sketch here. Now, some reasons we would do tolerances. 1, it saves us having to open this 44-page booklet and skim through these regulations every single time we want to make a change. Because if we put them right into our file, then we have them. We don't have to memorize them. We don't have to, earmark, dog ear our pages, highlight, anything like that. We can just come in here and we can see what it can be equal to. There's also another reason it's important, or helpful is a better word. There's also another reason it's helpful is you can actually flip between the different tolerances right in the program here. So really quick and easy, you can just see the difference in using the different values. So when you open up tolerance, because there was no tolerance on here, everything's kind of just grayed out. The first thing we have to do is choose the type of tolerance we want. Now for this one, I'm choosing limits stacked. And the reason for that is I have an upper limit and a bottom limit, and I'm just going to choose them stacked for visual. Okay, so my upper limit is going to be 34.0 millimeters, and my lower limit is 28.0 millimeters. So I'm going to set those right in here and click OK. Now if I change that dimension display that we just talked about and go to tolerance, you can see everything else looks the same, but this guy, because he has a tolerance on there, we can now see that tolerance right in our sketch. So we know that this diameter can be equal to 28, equal to 34, or anything in between the 2. Now, what if we want to play around with this value? So right now, if I jump back in here to value, we can see that this is equal to 28 right now, and this is what our wheel looks like. Now, if we want to see what 34 looks like, we can double click on this guy, go to our tolerance section, and set it to the maximum size. So this right here, we can see that this has the little plus button beside it. This is our upper tolerance, or our upper limit. So I'm going to set that, click OK. And if I go to, oh, it's going to lie to me here. Okay, so we set that. We saw it got a little bit bigger. What if I go to, there we go, precise value. Now we found a use for that one. So I changed that was a little quick. What I did is I changed my dimension display to precise value here, and it's actually telling me exactly what this is set to. So all I did was go in and change my tolerance to the upper limit of 34. Let's finish sketch. And we can see that really, I know it happens quickly, but really quickly, Inventor updated my wheel here so that it now has a diameter of 34. And if we go to check that, I can go to inspect, measure, and just really quickly check this, and we can see that it's 34.0. Now the beautiful thing about this is if I had my assembly for my car open, I could just hit that save button, jump into my assembly, hit the little update lightning bolt in the top corner, and this wheel in my assembly would automatically be updated. I could then check my interference. I could make sure that this wheel worked with my car body, it worked with the axle, it worked with my suspension system, everything else that's in my file there, I could quickly go ahead and check that. And if it maybe doesn't work, I can just jump back into this part, jump back into this value here, and set that back to the lower limit. And again, remember, today you might be thinking, oh, well, why don't you just double click and type in 28 or type in 34? The reason for that is I might not remember these two values a week from today. Let's be honest, I might not remember these 2 hours from today because my day's pretty busy. So having them in here already makes it really easy to just flip between the top and the bottom values. So again, that's a helpful little tool. It's not necessary for your design, but it is really helpful for you so that you don't have to constantly go through these regulations and reread them over and over and over again. So that's a little bit about using tolerances and parameters with our F1 wheel. Now these tools actually translate to all parts of your F1 car, putting in those parameters, naming them, and using tolerances to remember what those values from the regulations are.